Hello everyone, myself Shweta Shah, and we are here for the subject Computer Organization and Architecture, and we have started unit number 10, that is multiprocessor. In this unit we are going to see today the topic that is interprocessor arbitration and the interprocessor communication and synchronization. So now let us start with the interprocessor arbitration. So in the processors, in the shared memory multiprocessor system, the request to access the common memory or another common resources through the system bus. So if no other processor is currently utilizing the bus that you are requesting, the processor may grant you the access immediately. But if the requesting processor must have to wait if these buses are already occupied by the another processors, so it has to wait. And furthermore, the other processor also may request the system bus at the same time. So there must be some methodology by using that you can determine that which processor will access this bus. So the arbitration must be performed to solve this issue. And for that, we can use different methods. Like we can use the serial arbitration or parallel arbitration, or we can use the dynamic arbitration procedures. So in serial arbitration procedure, we are using the daisy chain arbitration. In this process, this arbitration process services all the processor requests on the basis of the established priorities. So the serial priority resolves this technique is obtained from the daisy chain connections for the bus arbitration circuit. And this processors connected to the system bus are assigned the priority according to their positions along the priority controller line. So whichever is connected first, that will have the closest to the priority line, that will has the highest priority. Okay, and using that priority, whichever the processor is having the higher priority, that can access the bus. And when the multiple devices are requesting at the same time that for using of the bus, the device with the highest priority will be granted for the access to this. Okay, so this is the serial method in which the highest priority is assigned to the system which is the near to the daisy line. Okay, so that way you can use. In the second method you can use is the parallel arbitration procedure. In that we will have the some external priority encoder, and that will decide that which processor will be assigned the bus first. Okay, so you can use that as well. Third method you can use is the dynamic arbitration method. In dynamic priority algorithm, that will give the system that capability of the changing priority of the devices while the system is in operation. So you can dynamically change the priorities at runtime. So there you can use the method like time slice. In time slice algorithm, it allocates the fixed length time slice to of the burst time that is offered sequentially to each processor in round robin fashion. So first one will have first, then second, then third, then fourth, and so on. Then in circular motion, all of the processor will have their turn to use the bus. So that is known as the time slice method, and this serves the this service is location independent. So all of the processor will have their turn to access the bus, and the no preference is given to any particular device since each is allotted the same amount of time to communicate with the bus. Now another method we can use is the polling. In the bus system that uses the polling, the bus grant signal is replaced by the set of the line that we can call as the poll lines. These lines are used by the bus controller to define the address of the each device connected to the bus. When a processor that requires the access recognizes that its address, it activates the bus line and then access the bus. After the number of burst cycle, the polling process continue by choosing the different processors. So turn by turn, each processors will be polled and they can transmit. And this polling sequence is normally programmable, and as a result, that selection priority can be altered at the runtime. Okay. Another method we can use is the LRU, that is the least recent used. That algorithm gives the highest priority to the requesting device that has not used the bus for the longest interval. Okay, and these priorities are adjustable after the number of burst cycles according to the LRU algorithm. With this procedure, no processor is favored over any other since the priorities are dynamically changed to give the every device an opportunity to access the bus. So this method you can use. Next method you can use is the FIFO. Here FIFO stands for first in, first out. Here in the scheme, the requests are served in the order received. So whichever order requests are received, they are served. Another method you can use is the rotating daisy chain. In this rotating chain procedure, the dynamic extension of the daisy chain algorithm that we have already seen. The highest priority to the unit that is nearest to that unit has most recently accessed the bus. So you can change the priorities by this way. Not the fixed priority that we have used in a series attribution, but you can change that priorities as well. Next, we are going to see is the cache coherent problem. To ensure the availability of the system to execute the memory operation correctly, the multiple copies must be kept and that should be identical. This requirement imposes the cache coherent problem. The memory scheme is coherent if the value returned on a instruction is always the value given by the latest stored instruction with the same address. So the cache coherent problem will exist in the processor with the private cache because you need to share the writable data as well. So we can see this problem with the example, like we have the one value element x and the value for that x is like 52. So this value will also be shared into private cache. So processor 1, 2 and 3 will have the value x is equals to 52 in that cache as well. Now, if we update these value in the processor 1 as a x equals to 120, then that can be updated into main memory as well, and that can be done by two methods like write through method and another is the write back method. In write through method, whenever you are updating in the subsequent processor like P1, P2 or P3, at that same time you will update this into the main memory as well. So here if we see that the in this first method, if we update the in P1 x equals to 120, then it will be automatically updated into the main memory as well. In second method, it is the write back method. In that, if we update the value in the private processor, then it is not at the same time that is going to be updated into main memory as well. It will updated in subsequent time whenever that whole block is stored in main memory. So at that time, it will be updated. Up to that, the value in the main memory will remain as x equals to 52. So this is the problem. Then if it is required to access 120 or 52, that is the problem, what you will access. So how we can solve this problem? That this problem can be solved by the method like first one you can do that disallow this private cache. So this is the simple scheme that you will disallow this private cache for each processor and have only a shared cache memory associated with the main memory. So any of the processor will change the data that is going to be changed into that shared cache only. So there will be no issue of the private cache. Another solution you can have is the software approach. In that you can use the read-only data that are the cacheable. So only those data that are the read-only that will be only stored into the cache. Other data that are writable as well that will not be cached. Okay, so that you can solve your issue. Another issue, another method you can use is the centralize the global table. In this scheme that allows the writable data to exit in at least one of the cache in mention that the employs a centralized global table in the compiler. So the value will be accessed from that central table only. Other than that, you can use also the hardware approach in that these solutions are handled by the external hardware automatically and it will have the advantage of the higher speed and the program transparency. And for that, for example, we can use the Snoopy cache controller. Okay. So here we are ending today's session. If you have any query, then you can contact.